Okay, some of you were here for 10.5, but I thought I would make a video lesson to go with it anyway. So we discussed the fact that factors are, and most of you said things that you multiply together to get a number. So if we did factors of 12, you get numbers or pairs like the numbers 1 and 12, because 1 times 12 is 12, 2 and 6, 3 and 4, right? So there's 6 factors of the number 12. Quadratic expressions also have factors. So the quadratic expressions you were used to in chapter 9 all looked like this form, with maybe an a in front of the x squared. So ax squared plus bx plus c was a quadratic expression that you worked with a lot in chapter 9. Today we're going to factor these expressions the way they are in chapter 9. This is called expanded form. Okay, so when we factor it, we're going to write it as a product of two different, this says linear expressions. I'll show you what that looks like, but it's going to be something, an expression, times another expression. So we're going to use back-to-back sets of parentheses to show that. I'm not going to have you worry about anything here because I think it sounds ultra confusing. So if we jump down to example 1, again, we're going to take it from expanded form, like this, 3 parts, a trinomial, and we're going to turn it into, I'm going to say 2 binomials. So each part in your parentheses will look like a linear expression that has 2 parts separated by a plus or minus sign. When your leading coefficient, the number right here, the number in the A position, is a 1, so we don't have to see it, but we can see it. When that leading coefficient is the number 1, you can go ahead and automatically put an x inside both your pairs of parentheses as the first term. You then need to find 2 numbers that multiply together to equal the last term. So in this case, it's going to be 15. The same 2 numbers. Whoops, I'm off the page there. The same 2 numbers will add together to equal the middle term, but without the variable. So they're just going to add together to make 8. Let me write 2 little, oh goodness, I'm sorry about that. 2 little mini problems. Blank times blank equals 15. Those same 2 numbers, when you add them, will equal 8. So if you think in your head a little bit, find 2 numbers that if you multiply them together, they equal 15. You take the same 2 numbers and add them, and they get 8. Hopefully you came up with the numbers 5 and 3. It doesn't matter if you write 3 and 5 or 5 and 3. The order when you multiply or when you add doesn't matter, but it's interchangeable. Once you find those 2 numbers, they're the numbers that go in the second position in this binomial. So I will write plus 3 and plus 5. Again, it doesn't matter if you write x plus 3 first and x plus 5 second. Okay, either one. But this is factored form, so when the directions say, hey, factor this, this is your answer. It's factored form. You really haven't solved anything. It's just writing this expanded form into something that's called factored form. Let's try example 2. Do exactly the same thing. Okay, so you have x squared minus 9x plus 20. You have a negative in this problem, but you're trying to find 2 numbers that multiply together to give you that last term, which is 20, and the same 2 numbers that when you add them, and you're always going to write an addition sign there, equals that middle term, but this sign on it, that makes that a negative 9. So when you add them, you get a negative 9. Here's where the negative numbers come into play. If you multiply a negative times a negative, so in this case a negative 4 times a negative 5, you get a positive 20. When you add them together, you're going to get that negative 9. And once you have the two numbers, you go ahead and separate your problem into two factors, each with an x in the first term. But because you have negative 4 and negative 5, you'll write minus 4 and minus 5. So let's see how the book calls that a linear expression. Like if I wrote y equals x minus 4 and graphed that, it would make a straight line, or y equals x minus 5 and graphed that, it would make a straight line. I just call it a binomial because it has two terms. But that is your factored form of that same expression. They equal each other. Okay, so this is factored form. There's reasons why you would use factored form to solve something over expanded form. So it's handy to be able to write both. So this is expanded form. Maybe you could pause here and try example 3. I'm going to go ahead and do it. But if you pause, just pause me. And then come back and listen, see if it's the same thing. Okay. So two sets of parentheses. When there's a 1 here or no visible number in front of your x squared, you can put an x in the first term. When there's a number there, you're going to do a different process. The process is explained in 10.6. I posted that video already. Okay. My two numbers have to multiply together to equal negative 8 and add together to equal negative 2. Okay, see what there with the negative signs? So thinking about two numbers, you multiply, and when you multiply them, you get a negative 8 as a result, and when you add them, you get negative 2. Hoping you come up with a negative 4 and a positive 2. They multiply together to give you the negative 8 and add together to give you a negative 2. So I'm going to write minus 4 and plus 2. That's how I'm going to write my answer. It is factored form of this expanded form. They equal each other. Boy, we have a lot of examples. All right, so here's another one. I'm going to go kind of fast. But x in the first, two numbers that multiply together to equal negative 18 and add together to make positive 3. Sorry about that. Okay, so if you think, like if you're struggling, go ahead and list the factors of 18. 1 and 18, 2 and 9, 3 goes into 18, 6 times. And then you might, when you look at the pairs, be able to see that if I'm adding the numbers that are 3 apart are your 6 and your 3. Think about which one would you make negative to get a negative 18, but when I add them, make a positive 3. Okay, so this is your result. It's factored form. All right, looking at example 5, we have an equal sign in the problem now, and the directions don't say factor. It says solve. So in all of chapter 9, when you were solving quadratic equations, whether you were using the quadratic formula, whether you were solving graphically, whether you were just, well, I guess that would be graphically, looking at a graph to find x-intercepts. Remember, x-intercepts are solutions. They're also called roots. Okay, so I'm going to play let's pretend here. Let's say that's 1, and this is negative 3. Okay, your solutions would be 1 and negative 3, right, when I was graphing. I'm just trying to review with you from chapter 9. They will not be the solutions for this problem. Okay, so first, I want to get that 10 to the other side, because if I'm finding x-intercepts, I want my y value to equal 0. These points, this point right here is a 1, 0. The y value is 0. This point over here is a negative 3, 0. They were x-intercepts. I want my y. If I subtract 10 on both sides, equals y, right? That's your quadratic equation. But if I change my y value to 0, then I'm finding the roots or solutions. So then I can go ahead and solve. But I'm going to solve by factoring. So I'm going to factor this. And I'm going to find two numbers that multiply together. Blank times blank equals -10. And blank plus blank equals -3. And my numbers should be a -5 and 2. So I'm going to write x minus 5, x plus 2. It turned out to be a +2. Okay, so you're going to solve for the x value that would make each binomial equal to 0. Okay, so I'm just taking this out of the parentheses right here, and I'm saying, hey, what would this x value be in order to make this equal to 0? So what number minus 5 equals 0? I think some of you it's just pretty automatic, but if I add 5 to both sides, x equals 5. On this one, if I do x plus 2 equals 0, subtract the 2, I get x equals -2. Oops, sorry, -2. Again, if I were to solve this graphically, my x-intercepts would be a -2 and a +5. You just solved it a new way. You factored it and found the x-intercepts, roots, solutions by using factoring. Okay, this is a long lesson. Tell whether the trinomial can be factored. So can you find in A two numbers that multiply together to make -7 and add to 6? For B, can you find two numbers that multiply together to make -5 and add to 6? So think about that a little bit. Blank times blank equals -7, but when I add the same numbers, I get 6. Can that happen? Your answer is going to be yes or no. Tell whether it can be factored. Yes, it can. No, it can't. No, it can't. Yes, it can. I don't know. Multiply two numbers together and make a -5. Add the same two numbers together to get 6. Again, you can pause if you want to practice that or think about that. I'm going to say on the top, your two numbers could be 7 and -1, because if you add them, it's really like 7 minus 1, which makes 6, and 7 times a -1 is -7. So my answer, tell whether it can be factored. Yes, it can. For letter B, I'm not thinking there's two numbers that you can multiply together to make a -5, and when you add them, get a +6. So no, it's not. So just because you can't factor it does not mean you wouldn't be able to use the quadratic formula and find solutions. It just cannot be written in factored form. So the discriminant. Remember in chapter 9 what the discriminant did for you? This was that b squared minus 4ac, that special part of the quadratic formula. In chapter 9, it told you how many solutions you'd have, how many x-intercepts. If you got a positive answer, you said there were 2 solutions. If you got a negative answer, you said there were no solutions. And if the answer was 0, you said there was 1 solution. It does another cool thing. If the discriminant, when you solve this little part, is a perfect square number, numbers like 0, 1, 4, 9, 16, 25, 36, 49, you know where I'm going with this? Okay, perfect square numbers. Then it can be factored. So if you're struggling to find numbers and you're struggling to factor, if you use the discriminant and it comes to be a perfect square, you got to keep searching for your numbers. Yes, it can be factored. Yes, you got to keep going. If the discriminant is not a perfect square, the trinomial cannot be factored. Again, it doesn't mean there's not a solution. It just means you can't put it in factored form. Last problem. It's a fun one, because math's fun. Okay, you have a garden. 6 yards by 15 yards. Here's your garden. You're going to put a stone path around the outside of it. And your stone path can be a total of 46 square yards. How wide? That's what our X stands for. How wide is this path? Alrighty, I'm going to use area of rectangles to find the area of a rectangle. So this one in particular right here. We're going to do length times width. If you look at that, the length is 6, just like it is on this side. It's the same distance, so 6. And its width is x. If I do length times width, I'm going to get 6x. That's the area of that rectangle. I'm going to do a similar area of this rectangle down here. So, oops, not the square over here, just this rectangle. So we're going to do 15 times x, length times width, 15x. That's the area of that rectangle. The little square that my thumb was covering up right there, length times width, is x times x. So x squared. In order to get the entire path, here to here, the square, over here, all of this together, I'm just going to add my sections. So I'm going to write x squared, that's the area of this, plus 6x, plus 15x, can equal 46. Alright, we're going to combine like terms. We're right there. X squared plus 21x. We're going to move this 46 over because remember we want a 0 there, so we're finding x-intercepts or solutions. So if I subtract 46, I'll write minus 46 equals 0. Factor it. You could use the quadratic formula, but this one, we're using factoring in this lesson, so I'm going to factor it. Find two numbers that multiply together to equal negative 46, while at the same time adding together to make a positive 21. Your numbers should be 23 and negative 2. So x plus 23, x minus 2. We are solving. Okay, so if that's my factored form, I need to say x plus 23. What if that were to equal 0? I subtract 23 on both sides. X would equal negative 23. One of my solutions. If I did x minus 2 equal to 0 and add the 2 to both sides, x equals 2. Here's the thing. This was a real life problem. This had to do with how wide in yards should my border be, right? How many yards should this be? Well, do you think I should have negative 23 yards of stone, or of my path, I guess, and negative 23 yards or 2 yards? So I'm going to say 2 yards. That can be the width of the path that I'm creating if I can only use 46 square yards as stone. Okay, the negative 23 doesn't make sense in this case. Sort of like when we were shooting the basketball up in the air, only getting one of the answers because the other negative number of seconds didn't make sense in chapter 9. Okay, that's it. That's probably the longest lesson you are going to get. That was a really long one, but it's kind of cool that you can pause it. Let me know what you think. If you have questions, feel free to email me, post them on the Google Calendar. You too could, like, you know, if you write something out on paper, feel free to either videotape yourself, audio tape yourself, take a picture of your work, point, you know, like, what did I do wrong right here, Mrs. Stofflet? However you need to communicate me, I'm here. Communicate with me, I'm here. See you soon. Bye.